Rational expression application. So now we're going to just use some applications of this. Male kangaroos flex their biceps to impress females. Who knew? Kangaroos aren't very different than like humans. Weird flex, but okay. Strange muscle enlargement, but fine. Odd chemical reaction causing signs of strength, but all right. Uncommon muscular fiber behavior indicating that you are doing well and showing off, but it is not necessarily an issue per se. Kind of funny. Okay. This one. So find an expression to represent the area of this rectangle. Well, we know that area is length times width. Fun. Well, so this is kind of a cool thing. So a square is a rectangle. But a rectangle is not a square. And that is because a square has all sides the same. So a square says that these two sides are the same. Right? And it says that you have all 90-degree angles here. But a rectangle doesn't say that. A rectangle, like the definition of a rectangle, is just that there are all right angles. But it doesn't care about the sides. So that's why a square can be a rectangle, but a rectangle cannot be a square. Cool. So here, let's just multiply them. That's length times width, right? Well, we're going to have to factor this. So the x squared minus 12x plus 27 factors to be x minus 3 and x minus 9. That x squared minus 81 factors to be x minus 9 and x plus 9. And then the 4x cubed plus 36x squared, well, we can factor out a 4x squared, and we're left with x plus 9. Cool. Now that 2 can cancel the 4. I'm left with a 2 on the bottom. Those x's can cancel. X minus 9's cancel. And x plus 9's cancel. So everything canceled on top, leaving us just with a 1. And on the bottom, I'm left with 2x times x minus 3. Cool. Okay, this one. If the area of a rectangular garden is a squared over b minus b, and the length is a over b plus 1, find the expression to represent the width. Well, let's just draw this. So we have some rectangular garden. The area here is a squared over b minus b, and the length is a over b plus 1. Normally, we'd just do length times width equals the area, but now we have the area. So to find the width, we're just going to divide the area by the length. So we're going to do a squared over b minus b divided by a over b plus 1. Okay, and we just need to make that first parentheses one fraction. So I am going to multiply, or I'm going to change it to b over 1, and I'm going to move the negative up to the top. Then I'm going to multiply that second fraction by b over b. So I end up with a squared over b plus b squared over b, which equals a squared minus b over b. So that's what the first fraction is. Let's do the same thing with a over b plus 1. So I need to get this to be one fraction, so I'm going to put that 1 over 1. Then I can multiply the second fraction by b over b. So I'm left with a over b plus b over b, which equals a plus b over b. Okay, and then dividing is the same as multiplying by the reciprocal. So it's a squared minus b squared over b times b over a plus b, which that a squared minus b squared, that's the difference of squares. So that's going to be a plus b and a minus b. So the a plus b's cancel, the b's cancel, and I'm just left with a minus b. Cool. Let's do this one. So find an expression to represent the area of a triangle. Well, the area of a triangle is 1/2 base times height. Who cares if school doesn't teach us how to raise a family or get a job? At least I can find the area of a triangle. Now, I'm not going to get into this philosophical debate with my computer screen right now, but if you want to know my thoughts about school and like what we should teach and blah, 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 I have some pretty interesting thoughts. It'd be a fun conversation. Okay. Anyways, so area is 1/2 base times height. So we have 1/2 times the base, which is x cubed plus 11x squared minus 26x over 3x times 9x plus 18 over 6x cubed minus 24x. Let's just factor everything. So I can factor out an x from that x cubed plus 11x minus 26. And then that can factor to x plus 13 and x minus 2. I can factor out a 9 right there, and I'm left with x plus 2. I can factor a 6x out right there, and I'm left with x squared minus 4. And x squared minus 4 factors to be x minus 2 and x plus 2. Now I can start canceling, so those x's cancel, those x minus 2's cancel. 3 goes into 9 3 times, but then 6 goes into 3, or 3 goes into 6 twice. So I'm left with a 2 on the bottom from all that. And then the x plus 2's cancel. So on the top, I'm just left with x plus 13. And on the bottom, I'm left with 4x, because 2 times 2 is 4. Okay. Let's do this one. So we want to find the volume of this. Well, volume... volume is length times width times height. So basically what you're doing when you find the volume is we're going to find like this. I'm pointing, but this right here. And then if you multiply it by the height, then that just fills in all of the rest of this. So you find the volume of a base, and then you multiply by the height. Okay, so you just multiply everything together. So here that's going to be x squared minus 32x plus 12 over 10x cubed times 18x squared over 4x squared minus 18 times x squared plus 14 plus 48 over 36 minus x squared. Lots of factoring. So that first one factors to 5x minus 2 and x minus 6. 45, we can factor out a 9x, and you're left with 5x minus 2. X squared plus 14x plus 48 factors to be x plus 6 and x plus 8. I'm going to change this so it's in standard form, so that's the same as negative x squared plus 36. I can factor out a negative right there, and I'm left with x squared minus 36, which is the difference of squares. So that's going to be x plus 6 and x minus 6. So then the 5x minus 2's cancel. X minus 6's cancel. 9 goes into 18 twice, but then 2 goes into 10 5 times. Those cancel, leaving us an x on the bottom, and the x plus 6's cancel. So I'm left with, oh, this is wrong, because we have this x right here also. So I'm left with x plus 8 over negative 5x squared, which can also be written, we can just move that negative in front, so this would be negative x plus 8 over 5x squared. Cool? Okay, this one. So to find the area of a trapezoid. Now, trapezoids are very important in calculus, because in calculus, you're finding the area under a curve, and you can use trapezoidal sums to do this. So to find the area of a trapezoid, it's 1/2 a plus b times the height. Now, the reason I want to kind of give you why, so maybe you'll remember this. We could take this trapezoid, and let's just break it up into 2 triangles here, okay? Now, both of these triangles have the same height. But say we were trying to find like the area of this triangle. Well, this would be 1/2. The base of this is b, and then the height is, I'm not going to put parentheses, we'll just call it h. And then if we're trying to find the area of this triangle, that's going to be 1/2 a times h. So we just have to add those two together to get the area of a trapezoid, right? So this is going to be 1/2 bh plus 1/2 AH, which those both have the 1/2 H in common. So I'm left with 1/2 H, and I'm left with B plus A, which we could rewrite this as A plus B times H. Okay, so that's where it comes from. It just comes from 2 separate triangles. So we can use that to find the area of this trapezoid here. So we're going to do 1/2 and then base 1, which will be x plus 3 over x plus x plus 9 over 2x times 12x over x squared minus 2x minus 35. So I need to add those two fractions together there. And it looks like the first one is just missing a 2. So I'm going to multiply that by 2 over 2. So that's going to be 2x plus 6 over 2x plus x plus 9 over 2x, which leaves us with 3x plus 15 over 2x. So that's just going to replace that right there. Now we can factor everything, so I can factor out a 3 right there, and I'm left with x plus 5. X squared minus 2x minus 35 factors to be x minus 7 and x plus 5. Now those x plus 5s cancel. 2 goes into 12 6 times, and 2 goes into 6 3 times, and the x can't cancel, or the x's can't cancel. So on top, I'm just left with 9, and the bottom, I'm left with x minus 7. And that's the area of that trapezoid in terms of x. Okay, let's do this one. So we want to find the surface area of this, which surface area would just be like all of the area on the outside of our box. So the first thing I'm going to do, I'm going to find that area right there, which it looks like the base of that is 6 over x, and the height is 3 over 2x. So I'm just going to multiply those together. And I get 18 over 2x squared, which equals 9 over x squared. Now, if you think about this, so this is the same as the area on the back side of this, right? So we have two sides with that same exact area, which means I am going to multiply 2 times the back side of this. So that's going to be 2 times 9 over x squared, which is 18 over x squared. Okay, I'm going to do the same with this side piece right there. So the base of that is x over 4, and the side is 3x plus 3 over 2x. So it's x over 4 times 3 over 2x, which is 3x over 8x, which is just 3/8. But again, if this side is that, this side over here is also the same. So then I can multiply that 3/8 by 2 since we have two sides like that. So 3/8 times 2 is 6/8, which is 3/4. Okay, we're going to do the same for the top. And that's going to be 6 over x times x over 4, which is 6x over 4x, which is 6 over 4, which is 3/2. And same exact thing, if the top is that, so is the bottom. So 3/2 times 2 is 6 over 2, which is 3. So we've found everything now. We just have to add it all together. So we have 18 over x squared plus 3/4 plus 3. To add these, we have to get a common denominator. So I'm going to put that over 1. And it looks like our common denominator is 4x squared. So I'm going to multiply the first fraction by 4, the second fraction by x squared, and the last fraction by 4x squared. So I end up getting 72 over 4x squared plus 3x squared over 4x squared plus 12x squared over 4x squared, which 12 plus 13, that's 15x squared, and then plus 72 over 4x squared. Okay, cool. Looks like we're done here. Bye, guys.